Hey guys, BuildZoid here, and today we're going to be taking a look at another DDR5 overclock, this time on the Maximus Z690 Apex motherboard. This is a early retail motherboard that I purchased around launch, so yeah, big thank you to the support, like patrons and anybody who buys anything on Teespring for supporting the channel, because without you guys I wouldn't have this board. Fortunately, it's not that great, but we'll get to that. The CPU is, of course, the 12900K that I have from Gigabyte, and I'm also using the Gigabyte Aorus engineering sample memory kit that I have, which uses 16 gigabit SK Hynix chips, and the memory sticks are single rank, and they're both 16 gig DIMMs, so 32 gigs of memory in total, and yeah, so also the CPU is cooled by a 360mm custom loop with liquid metal on top of the IHS. Also, there's a washer mod, which is why you can see the electrical tape around the socket. That's so that that's for the basically to just because I'm using metal washers, so that's to protect the PCB from them. And other than that, I guess there's a fan sitting on the memory sticks, which you can see, which like if you're overclocking any DDR5, you should have direct airflow over the memory sticks because DDR5 has the power delivery on the actual memory stick itself, and consequently DDR5 memory sticks run a lot hotter than DDR4 memory sticks do. And they're also temperature sensitive. So if you want to be pushing, high overclocks, yeah, you need to make sure that your memory sticks, like you don't need to go crazy on it, but you do want to make sure that they get direct airflow. So that's why I have the fan sitting on the memory sticks. Now then, I mentioned that the board is a early retail motherboard, and the reason that I mentioned that is because uh, basically it turns out that Asus, at least for their for the thing is, I'm not sure how widespread this is, but I know for sure that Asus, at least early on, was binning these boards for signal integrity. Which makes sense, because, for example, on my board, the A and B memory, so the B channel can actually boot memory speeds all the way up to 7,200 megabits per second. The A channel hits a brick wall at 6,600 megabits per second, even on the latest BIOS, which is actually kind of horrible. And the thing is, there are screenshots from people who were, who got motherboards directly from Asus ROG. So a lot of the overclockers that Asus works with, who have boards that'll quite happily boot 7,000 plus megabits per second with 2 memory sticks, which my board will absolutely not do. And I know for a fact that they were sorting motherboards for signal integrity, at least early on. I've also heard that later production retail boards, especially from I think January this year, I'm not sure if it's that the boards are more consistent or if the boards are just way better across the board. So I don't have details on that. But basically, if you have an Apex and you bought it close to the Z690 launch and it sucks, it's because it sucks. That's basically what's going on with that. It's not that you're doing something wrong. The early boards are a lot of the early boards are just apparently really bad. So well, still not quite as bad as a 6-layer 4 dimmer, but they're not great, and they're very well, I don't know, I only have one board, so I don't know how much variance there is board to board. But the Apex, at least this board is very touchy with the voltages. It's very different from all of the other boards that I have, and we'll see that when we get to the actual BIOS and I show you all the settings. Because yeah, you the way you set voltages on this board just completely different from how you do it on any other motherboard that I've worked with for DDR5. It's I don't know what Asus did, but this is nothing like a Gigabyte or an MSI board. And I'd argue that's for the worse. But anyway, let's take a look at what I managed to do with the board that I've just been complaining about. So basically, since the board can't do high memory speeds, well, the thing is, it might also be I've finally sort of figured out how to deal with the voltages, so maybe I'll be able to eke out a 6600 that's actually stable instead of something that immediately blue screens trying to get into Windows. But Yeah, the board basically doesn't do high memory speeds, and I'm not sure that that's going to change. So instead of wasting time trying to get like, 6400 megabits per second or 6600 megabits per second working with 2T command rate at some random, probably terrible timings, I decided to instead focus on the one strength that this board kind of used to have, because at this point even Gigabyte has a BIOS for the Tachyon that does 1T command rate. But early on, this was one of the, well, I think the Unify X also, straight from the get-go, did 1T command rate. But like this board does do 1T command rate, which not all DDR5 motherboards do 1T command rate. So that's really neat. And so instead of wasting time trying to force the board to do things that I don't think it can do, I focused on just maxing out the performance using 1T command rate, which gives you it does give you a nice little performance boost, being on 1T instead of 2T. Like the thing is, if you can clock the memory high enough, you can completely negate the disadvantage of 2T command rate compared to 1T command rate. So, yeah. But since this board doesn't clock high, I was like, okay, well, I'd rather run, what we're running here is like 6180 megabits per second with 1T command rate. Like, I'd much rather run that with 1T than like 6400 megabits per second with 2T, because 200 megabits per second, like, it's something, but it's not enough to offset the command rate difference. So that's why I sort of settled for less speed and tried to really focus on dialing in the timings, which which sort of, like, the thing is, there's not that much headroom, I'd say. There's not that much variance. But yeah, anyway, so 6180, 30, 37, 37, 42 for the primaries. And then here you can see memtweak. We'll go through the timings in more detail in the actual BIOS, because, like, for example, the TWR, I'm not setting that in the BIOS. Well, I'm not setting the TWR timing in the BIOS. I'm setting that through other, like, the TWR pre and, where is it? The TWR pre-DEN timing over here. TRFC of 300. We'll go through the timings later. So stability, 700% mem test passed. So the memory is happy. LinPack passed. Y-Cruncher runs. Y-Cruncher is rather slow, as you can see, because I am running this without AVX 512. The reason why I've chosen to run this without AVX 512 is because Intel has actually just made a statement that they are going forward, they are going to be disabling AVX 512 in hardware for newer production 12th gen CPUs. And mine is an early CPU, so I still have support for AVX 512, but I don't think there's much point showing AVX 512 performance when a lot of CPUs don't have won't have AVX 512 support in the future. So yeah, all of this was done with just AVX2. I'm actually really pleased with the LinPack performance. Like, I think 650 is one of the... This might be the straight up the highest LinPack gigaflops that I've seen that are actually stable. Like, I've done higher, I think, just for fun runs where it wouldn't survive. This is 36 loops of LinPack, or like it would maybe do a couple loops of LinPack, but it wouldn't survive mem test. So I've had overclocks that, like, I've managed to go higher than this, but for like full stability where it passes 36 loops of LinPack and also 700% mem test, I'm pretty sure that is the highest gigaflops I've seen. And also the average of 649 is just the very, very solid LinPack extreme results with AVX 256, especially with the CPU at 5.25 gigahertz, which is basically the limit of what this CPU is going to do for, like, LinPack stability. Also, here's the Intel memory latency checker, which is basically, so this, I'm not using IDA because I do have a BCLK overclock on this, right? We're at 103 BCLK. And the thing with IDA is the IDA benchmark just completely breaks down once you start overclocking the BCLK. So this, on the other hand, this only works on Intel CPUs. It doesn't work on Ryzen CPUs, but this doesn't break when you raise the BCLK. This works fine. So that's why I'm using this and not using IDA. The latency numbers are relatively comparable. Anyway, so here's the Intel memory latency checker results. And Yeah, also it's worth noting that LinPack on 12th gen CPUs is far more memory latency sensitive than it is sensitive to memory bandwidth. So like, yeah, I'm actually really like this LinPack, like I'm really pleased with the LinPack performance. Like this overclock doesn't have a ton of bandwidth, which you can see here in Intel memory latency checker, right? Like it tops out at like 97 gigabytes per second, which makes sense because we're at only 6180 megabits per second, data rate. So considering all the other inefficiencies that are involved with memory, yeah, this isn't going to be hitting some like 100 gigabytes per second plus, bandwidth numbers. But the latency is really quite low, and that's why LinPack is actually very pleased with this, which is kind of nice. Y-Cruncher is more about memory bandwidth though than latency, but even Y-Cruncher is doing okay for for 5.25 gigahertz with AVX2. So yeah, so it's stable. I've not done a reboot test. I will do one if that doesn't go well. I'll leave a comment saying if the overclock survived a reboot or not. But the thing is, yeah, like I just want to get this video done, so because I've spent way too much time on this. But I don't expect this to have reboot instability because the memory speed is quite low, right? At 60, like we're under 6200 megabits per second. I can't imagine that this would have like reboot issues. Usually those for me, those have usually showed up at like, well, depending on the board, above 6200 megabits per second. And while I was working on like dialing this overclock in, I didn't really have any scenario where the stability wasn't coming and going randomly, which is what you usually notice with some of the when you push a board too hard. What'll sort of happen is like you'll make a setting adjustment, you'll think, oh, this will improve the stability, and then like the stability out of nowhere goes straight to hell after a reboot. And then, you make another minor adjustment and suddenly it's very stable. And then you make, so I've not run into that. Like the process of dialing in this overclock in was basically, it was very unstable to start with. And then it slowly got better and better and better. So there wasn't any sort of random ups and downs in the level of stability that I was, seeing in the stress test. So I don't believe this will have reboot issues, but I haven't checked that yet. And I will, and I'll leave a comment if it works out. But yeah, I just want to get this video done at this point. So here we are. So yeah, all around, I'm, it's not really pushing the limits of DDR5 memory speeds, but it is stable. The performance is acceptable. Kind of disappointing considering how expensive the Maximus Z690 Apex is, but yeah, well, the thing is, to some extent, I think the CPU could be at fault as well, because I've not really had amazing results with the CPU on any of the other boards. So anyway, let's just restart, and I'll show you the settings in the BIOS. It takes a while to post. There we go. But like it takes a while all the time. I think it's just tied to the 1T command rate on that. Anyway, so I do have XMP2 enabled, which shouldn't be necessary, if I'm not mistaken. But yeah, I do have that turned on. The XMP profile is not being used, of course. So we're on the 60x memory ratio, so with 103 BCLK, that works out to 6180 megabits per second. The all-core ratio is at 5.1. The cache is at 4.7, so that ends up being 4.85 in the OS. Core voltage, I have it set to 1.43 with the LLC at level 5 for the V-core and level 2 for the VCC in. I've also maxed out the CPU current capability, and I've disabled the VRM spread spectrum. I've not done anything. Oh, I also seemingly set the VRM controls to extreme, but yeah. Anyway, so that's the VRM settings. I guess technically 5.25 for this CPU, 5.25 is quite a CPU overclock. So we're kind of going over the CPU settings as well. I have the E-cores disabled, so that's why I'm not doing anything well with the L2 cache voltage, with the L2 voltage, because you don't need to worry about that if you don't have E-cores turned on. And this is the first super weird thing about this Apex. I'm not sure if this is universal to the Apex boards, but with this one, it really doesn't like high system agent voltage, like at all. In fact, this board doesn't like the system agent voltage as it's set by auto settings. Like if I if I enable XMP on this board, the system agent voltage goes to I think 1.2 or 1.25 volts, and that's too much system agent voltage for this motherboard. And the result of too much system agent voltage on this board is random, they're not really lockups. The system just randomly resets. You don't get a blue screen, no warning, nothing. It just shuts down and restarts out of nowhere if your system agent voltage is too high. So if you have an Apex and you're experiencing just random shutdowns, especially under load, where it doesn't blue screen, it doesn't, no warning, it just dies. And your system, and you have the system agent voltage set above 1.1 volts, it's probably because your system agent voltage is too high. So yeah, I have it all the way down at 0.95 volts. Raising this voltage just doesn't help anything on this board in my experience. If anything, it seems to and if you raise it too much, it just seems to cause issues. So yeah, that's why I'm at a relatively low system agent voltage. Or actually not even relatively low. This is a very low system agent voltage. It is worth noting that since, with DDR5, you're always going to be in gear 2. You're going to be in, gear 2 or gear 4. And because of that, your memory controller clock is actually going to be really low, so you shouldn't even need a lot of system agent voltage anyway. But yeah, it is super weird. On a lot of other boards, bumping the system agent voltage actually helps with stability, especially into maybe the 1.2 to 1.35 volt range. On this board, if I use 1.35 volts, it'll die while sitting on the desktop. It is absolutely unusable with high system agent voltage, which is I've not seen that on any other board. Super weird. Took me way too long to figure out that is an issue. Yeah, so that's a thing. I've slightly bumped up the CPU VCC in voltage to 1.82 volts. I have the high DRAM voltage mode enabled. I don't know how good the support from Asus is for the various power management ICs on DDR5 memory sticks, but these Gigabyte sticks use, I believe, a Renesas power management IC, and evidently the Apex has support for those. So, has support for this power management IC. So, yeah, that's enabled. It works, and I have the VDD set to 1.5 volts and the VDDQ set to 1.45 volts. The VDD voltage is basically, the easier way to explain it is the VDDQ voltage controls the I/O portion, it powers the I/O portion of the memory chips, and the 1.5, the VDD voltage powers the rest of the memory chip. So this is the part of the memory chip that actually talks to the memory controller. This is this is internal to the memory chip itself. A lot of the time, it's best to set both of these to the same voltage, but with this board, I've been running into... this board is just weird. So on most boards, I would just set everything to, VDD and VDDQ. I'd just set them both to 1.5 volts, but with high... I've just been having stability issues with higher voltages in general. So one of the things, one of the settings I was trying to stabilize with this board early on was, CL28 at 6180 megabits per second. And for that, in order to boot, I needed 1.55 volts. Actually, no, it would boot with 1.5 volts VDD and 1.5 volts VDDQ. But the problem I was running into was just instability late into various memory stress tests, and I couldn't find a way to fix that. Like, more voltage just made it worse. Less voltage made it also worse, so I just kind of ended up giving up on that and just decided that this board with this memory really doesn't seem to like more than 1.5 volts on any of the VDD rails. So yeah, that's why these are set the way they are, because even like 1.5 volts VDDQ certainly doesn't help in any way, and if anything, it might have been causing issues. So that's down at 1.45 volts. Then advanced memory voltages, I have the IVR transmitter VDDQ voltage set to 1.5 volts, which is very odd, because on a lot of other motherboards, I really don't need it this high. I'm also not entirely certain that this is safe for long-term operation. Asus doesn't ever change the color of that voltage. And this is an internal CPU power rail. Like, this voltage is generated by the integrated voltage regulator, and this goes to the memory controller, and as far as I'm aware, it doesn't go to the memory at all. At least according to any of the documentation I've been able to get my hands on, this voltage is like it seems to be a replacement of the VCCIO2 rail or something similar to that. And so if you're not feeling brave, I would generally recommend that you try to stay below 1. I would say you'd actually want to be at like 1.45 volts, but I can't pass LinPack with 1.45 volts. And so, like, because the thing is, like, if I lower that voltage, I need to loosen out the primary timings. It really, like, it's not like a memory speed trade-off. It's just like, I can't run CL30 with 1.45 volts of VDDQ transmitter voltage, which is super weird. Actually, well, the more weird thing is that actually on this board, the IVR transmitter VDDQ voltage has to be the same as whichever, like, or has to be the same or higher than your highest DRAM VDD voltage. So because my DRAM VDD is 1.5 volts, I need to have that integrated, like the transmitter VDDQ at 1.5 volts as well. If my VDD was at 1.45, then I could run the transmitter VDD at like 1.45 as well. But with the DRAM VDD at 1.5, if I try to run a lower transmitter VDDQ, it doesn't work. So it like won't post. So that is super odd, because I've also not encountered that on any other motherboard. Really this is super weird. I just, like, on Gigabyte, I regularly use like 100 or 50 millivolts less VDD, transmitter VDDQ than I do memory voltage, like memory VDD or memory VDDQ. And the same goes for MSI, where it's called CPU VDDQ. Like, those boards have no problems with having this voltage lower than the memory voltages, but this board, if I set this lower than either of the, than the highest of the two of the memory voltages, it doesn't work anymore. So, or more like it won't post anymore. So that's kind of that. Memory controller voltage. So this is another wacky one. So this is the voltage used by the memory controller to actually communicate with the memory. Which you'd think would have to be closer to the voltage that the memory runs at, but Asus motherboards, man. Like, on Gigabyte, this voltage, I normally use it really, really high, and it's perfectly fine. This rail, like, replaces the old DDR rail. But, yeah. The thing is, on the Apex, this voltage has well, actually, on all motherboards, this voltage generally has, like, a sweet spot effect, where for a given set of memory settings, there's like an optimal VDD2 voltage. Also, I hate that Asus just doesn't use normal naming schemes. To be fair, Gigabyte is also bad with naming things, but there's no mention of such a rail as memory controller voltage in the Intel documentation, so I'm super frustrated that they've decided to call it that. Like, it's not wrong, it's just that nobody calls it that except Asus. Anyway, yeah, so this voltage sweet spots, with 1T command rate, it actually has to be lower than with 2T command rate. With 2T command rate, like 1.35 volts or something like that, or even, well, 1.35 volts is about the limit for my board with this memory kit. Like, it's all super board and memory kit dependent, so unfortunately, If you're trying to copy my settings, even if you have an SK Hynix-based memory kit, it'll probably not work. Uh, unless your board behaves exactly like mine and your CPU also behaves exactly like mine, which is very unlikely because the silicon lottery is unfortunately very real. But yeah, so with this voltage, basically be careful. Like, don't try to setting this voltage too low, bad. Setting it too high, also bad. And for the settings that I'm running here, the optimum setting is like 1.287 volts. And this is literally just trial and error. I tried 1.3. Actually, I think I had the voltage all the way at 1.4, and at that point, I think it starts causing the board to have issues posting. So yeah, spent quite a bit of time just sort of moving that voltage around and seeing what it does to stability. Took a while to get it to this level because there's sort of as you get close to the ideal voltage, the instability starts getting less and less and less. So at 1.25 volts, it was kind of stable. At 1.3 volts, it was kind of stable, and it took forever to actually cause any errors, but it eventually did. And so, yeah, I sort of settled on this voltage that's sort of in between the two, and that worked out fine. Then down here, we just have a repeat of the DRAM voltage, like the DRAM VDD and VDDQ voltages, so those are the same. Literally, these two are the same thing as these two, right? Literally the same settings. Then we have the VPP, which I've bumped up from 1.8 to 1.9. This shouldn't be necessary, but this board, this board is a nightmare, so I was trying everything to try get it to stop being horribly unstable. So that's why that's at 1.9 volts. This shouldn't, I don't think that actually helps. This really shouldn't actually, this shouldn't be necessary at all. Unless you're trying to run extremely high memory voltages, you shouldn't have to do anything to the VPP rail, which I'm not doing that. We're at just 1.45, 1.5 volts. So bumping up the VPP to 1.9 is, it should be completely unnecessary, but at this point, I'm just happy that it runs. And 1.9 is perfectly safe for the memory. This isn't going to cause damage. It's just, it also probably isn't necessary. But I'm not, after all, spending this much time on this, I'm not willing to take the risk of, lowering the voltage and finding out that, actually, yes, that was necessary. So that's just there to stay. Then the switching frequencies are all maxed out. Which, yeah, Apex things. I'm not sure that that's necessary, but a similar situation as the VPP. This isn't going to damage the memory sticks. Yeah, I'm not sure if this is actually necessary for better overclocking. It's just, I don't want to deal with it if it is. So, and then I've also maxed out the DRAM current capability. So anyway, that's all of the, that's not all of the voltage settings. That's most of the voltage settings. There's more. Let's go into the tweaker's paradise. Luckily, all of this upper stuff you don't really need to worry about. Most of this is to deal with extreme overclocking and dealing with weird issues that come up on liquid nitrogen. And then we get to the PLLs. So core PLL, so raising the core PLL basically helps stabilize high CPU frequencies. So since we're at 5.25 gigahertz, that I've bumped that up a bit. My ring PLL is 0.975, system agent PLL 0.975, and memory controller at 1.02. And basically, so this helps with ring stability a little bit. There's a sweet spot effect to this, it really depends on your CPU, but my CPU generally likes it at 0.96, 0.975, this sort of range. And then system agent PLL, same kind of thing. Yeah. And there's no requirement, your CPU won't need them to be, these two to be the same thing. It depends on the CPU, and mine is perfectly happy with these, so that's what I'm using. Memory controller PLL at 1.02 volts, which helps a little bit with the memory stability. So that's why that's bumped up. On other boards at different memory settings, I've also used 1.05 PLL voltage, so for the memory controller. Anyway, let's finally take a look at the actual memory settings, shall we? So, wait, actually, AVX controls. Yeah, you can see I have AVX 512 disabled. Anyway, DRAM timing controls. So Maximus tweak is in mode 2. I am not sure if mode 1 wouldn't work. I've not tested that at this point. I am not willing to test that. Then we have the primaries of just 30, 37, 37, 42, command rate of 1T, or 1N, I should say. It's not really technically. It's 1 tick. It's 1 tick of memory controller clock, which with gear 2, which we're in, right? Because if you look up here, well, actually, I didn't bother to set that. Nope, that's the BCLK to DRAM. Yeah, so we're on the 1 to 2 setting on auto. The 1 to 1 setting, by the way, just doesn't work with DDR5 at all. So don't even bother trying to use that. Anyway, but technically, so 1 tick of memory controller clock, which is half the rate of the memory clock, which is half the data rate. There's like 4 levels actually no, 3 levels of things running at twice the other thing. But anyway, so 1T, and this does provide a nice little performance boost. Like, that's probably most of the reason why the LinPack results aren't completely terrible, considering that we're at 6180 megabits per second. TRRDs are 6 and 4. 5.4, I think, might actually work at these settings. 4.4 works for benchmarks most of the time, but I've had issues with, like, fully stabilizing it. So, anyway, here I've managed to dial in, like, 6.4. Or, well, this is stable with 6.4. Also, the performance difference between 4.4 and 6.4 is not really... It's not much. So... yeah, anyway, DRAM refresh cycle 2, I've set that to 344. I do believe the Asus BIOS actually corrects for this, because on some other motherboard BIOSes, the refresh cycle time setting, this on some other motherboards doesn't work at all. But since I have a bunch of motherboards where you're supposed to always set the refresh cycle time to, I'm just sort of doing that everywhere now. So, like, any board where you have both of these, I just use the cycle time to. Especially on Gigabyte, because the other timing doesn't actually, like, it. I don't believe it won't apply, I think. So, like, if you try to set it, it'll do nothing. Anyway, so this is set to 344, and that sets the refresh cycle time to 344, which is about as low as you can push the... Actually, at 6180, I might be able to push it a bit lower, but generally it doesn't go below 300. Like, low 300s is about as low as it goes for SK Hynix memory sticks. For other memory sticks, I believe the limit is usually somewhere in the 400s. So, yeah. Anyway, refresh cycle time, same bank, is at 244. Wait, same bank? Other boards call it per bank. Man, Asus and naming schemes. I love that. Anyway, that's a 244. Generally, this can be a bit lower than the refresh cycle time itself. Then we have the refresh interval, which is at 65,000. Technically, you can set it above that. Like, let's just see where it maxes out. Yeah, so you can max it out at that. But I have run into instability with completely maxing out the refresh cycle time. In the past. So, and also, well, there is actually quite a performance uplift if you go from like 65,000 to 120,000 or even like 260,000. But, yeah, honestly, for like 24/7 operation, I'm not really willing to risk it. So, yeah, that's at 65,000. Like, it is possible that more would work, but I'm not willing to find out. Let's put it, like, for benchmarking, sure. For daily, I wouldn't bother. Then read to pre-time is 8. I believe 6 might work, but I've not tested that. 4 active window is 16. This, well, the Asus BIOS won't stop you from trying to set it lower, but it doesn't go lower. The way this timing works is it actually just acts as an extension on top of the TRRD timings, or RAS to RAS delay timings. And so basically, if you're, which incident, do they let you set those? Oh, they do. Of course they do. So both of these bottom out at 4, okay? Like, literally, the register on the CPU does not allow you to set these below 4. So the fact that the Asus BIOS lets you punch in a 3 or a 2 is, like, if you set them to a 3 or a 2 or something, like, the CPU will just reinterpret that as a 4. In fact, I'm not sure that the CPU will have to reinterpret it at all. I think the BIOS just turns that into a 4, probably. Because, yeah, you can't set those below 4. Anyway, and the 4 active window basically adds a little bit of, like, adds extra unused clock cycles on top of your TRRD timings. So what would potentially make sense is, like, let's say you have a memory kit that has pretty weak, like, needs a higher 4 active window. It could make sense to run something like the 4.6 that I have, but with like a 4 active window of, I don't know, maybe 18. It wouldn't really make any sense to run it with a 4 active window of 20 because that would be the same as just doing this. So, yeah. Anyway, under most circumstances, I would just like set the 4 active window to 16 and then only worry about the TRRD timings, because trying to dial in the 4 active window to me seems like a waste of time when you have two perfectly good TRRD timings that you can play with instead. So, yeah. Anyway, CKE minimum pulse width at 4. This literally doesn't go below 4, so that's as low as it'll go. Cast write latency at 30. I tried to 28. It wasn't stable, so it's at 30. I'm going to keep going down. So tertiary timings. 11.7 for the read-to-read same group. Well, for the read-to-reads, so same group and different group, so that's referring to the bank groups in the memory. These do not go lower than this. 11 and 7 is as low as you can push these, as far as I know. I've never been able to run them any lower. I don't believe I've ever seen them set any lower than this. Though I think you might be able to glitch out the memory controller into at least reporting that they're lower than 11 and 7. But yeah, trying to set these lower than this generally, like, it's not going to work. Also, if you're having stability issues with 11.7, 12.8 basically always works. I've not had issues with 12.8 under almost any circumstances. So yeah, but as tight as you can go is like 11.7 in my experience. Then for the read to write and the same group and different group, those are just both on 20 because you can sometimes push them down to 18, but I can't be bothered. And yeah, so those are at 20. Then the write to write same group and write to write different group are at 11.7. Again, these don't go any lower than this, and a lot of the time you might get stuck at like 12.8 instead of being able to run 11.7. And for the write to read same group and write to read different group, 62 and 46. These two are kind of annoying because if you set them a bit too low, you're gonna get you're gonna get random errors late into stress tests. Is kind of what you're gonna run into. Like, it's not gonna be immediate that they're too low. Also, the lower you set, also these two will actually somewhat trade for your primary timings. So you might be able to run lower. You might be able to set these two slightly lower if you run looser primary timings, but, yeah, like, we're just going to go with what I have here. And actually, they're not going to go much lower than what I already have. Like, the 62 is quite loose. Like, the 62 is quite loose. A 56 is doable in a lot of, like, in certain configurations, not in this one. But, the 46, like, the absolute lowest I think I've ever run the write-to-write different group is, like, 44. So that's actually not getting any lower than it is right now. At least not by an appreciable amount, so yeah, anyway, then all of the other timings that you can see here set on auto, these are for different rank and different DIM. And since this is a single rank memory configuration with one DIM on each channel, these timings are not relevant. So those are all on auto. And then for the TWR pre and TWR pre-DEN, TWR PDEN, I have those set to 51, and that's how the TWR ends up being 16 when we're in the OS. It might be possible to set these even lower, but this board has given me weird issues when I was trying to push really low TWR time. Like when I was trying to push the TWR timing really low. So 51 and 51 is kind of like where I'd stop with this. Yeah, anyway, then down here we have TXP and TPPD. You can just set these to 4.0. It gives you a little bit better memory latency, and there's really there's no downside to just setting these to 4.0. I've not ever heard of these causing stability issues. So, Yeah, anyway, other than that, also down here, the DLL-BW bandwidth selection, I have that set to 25. I wish I knew what that setting does, but none of the documentation I have access to even mentions it, so yeah, but 25 helps, seems to, well, like the board says, over 22 can help with stability, and 25 works for these settings that I have here, so I'm just going to leave that at 25. Yeah, there is more, unfortunately. We need to go into the memory training algorithms. So a big part of getting this stable, and big thank you to the person on the AHOC Discord who told me this, was actually disabling some of the training algorithms that the board has. So the main one was the sense amp offset training. Disable that. If with this enabled, the board was so bad at high memory speeds. Like, it was just a flood of errors. It was ridiculous. Like, I have no idea how it was so bad. Not sure. Yeah, no, I didn't change that. Oh yeah, then round trip latency enabled. This helps with stability and performance. And then turnaround timing training is disabled. And unfortunately, I set all of these training options at the same time. So I'm not sure. No, I don't believe I said. Don't believe I. No. Yeah, that's disabled by default. The margin check limit. So, yeah, basically, I set these two. Well, these three settings is just turnaround timing training disable, round trip latency enable, and the sense amp offset training disabled. And with that, like, a lot of the big stability issues went away, and then it was just usual memory overclocking like you would do on any other board, except for the really weird voltage settings like the very low system agent voltage and the weird behavior with the VDDQ, like the transmitter VDDQ and the regular VDD, like the DRAM VDDs. So, yeah, this board is annoying, to say the least. Now, I want to save a profile, because I want to check. So, I want to check what happens if I set the system agent voltage to auto, because I'm pretty sure it'll go to something absolutely ridiculous. So let's check that. Like, it'll still be able to boot, it just won't be very stable at all. Actually, it might not boot. Oh, no. The 0D postcode, I think, gave me... I think it's Ryzen where you don't want to see that one? Yeah, anyway, that booted right up. It just takes a while. Oh, there we go. Oh, it's actually using a sensible amount of system agent voltage. That's weird, because I was having, like, massive stability issues even when XMP was just turned on. Anyway, yeah, so that's... Like, if you have an Apex and it's randomly just dropping, and, like, just randomly resetting itself, lower this, like, check if your system agent voltage is too high, because that's what was causing it for me. Anyway, I'll set that back to 1.95 now, and I'm going to go start another memory test, and hopefully it won't immediately just throw errors. Actually, let's just keep this like that. So hopefully this is somewhat helpful if you have a... Like, I assume that a lot of the weirdness that I have to go through with this board is related to this being an early production board rather than, like, a more recent board. Yeah, so if you have an early board and it's being weird, then sort of try something like this. If you don't do a lot of the, like, if you don't adjust the training algorithm settings, the board is almost like, so without adjusting the training algorithm settings, the most I could get out of this board to actually pass mem test was like 58 megabits per second. So like I couldn't even do 6,000 megabits per second stable. Anyway, so now I'm just going to start my memory test. And that's the end of the video. So yeah, thanks for watching. Like, share, actually, the sun came up and the camera is totally blown out. I guess we'll just end on this then. So yeah, that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's also the HOC Teespring store, where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel because they allow me to buy motherboards like the Apex here, which evidently would, like, I should have just waited and bought a more recently produced one instead of buying one right at launch, because like, the whole reason the board hasn't been in many videos is, like, it's been a massive struggle to use this board just ever since I got it. So, yeah, I just didn't, I never managed to get anything worth making a video about, so there wasn't a video. But anyway, yeah, I'm finally starting to figure the board out, sort of, and, yeah, this is all made possible thanks to the patrons and people who buy stuff, like, on Teespring, so yeah, if you'd like to support the channel, there are links in the description. And that's it for the video, so thank you for watching, and goodbye.